how has crash testing evolved over these 20 years? What has changed? What is different? What have you added to the initial contact you had with it?
I mean, I think what has really evolved is our computer simulation capacity. So the capacity to replicate the world in computer models. So we can actually crash the cars many thousand times before we have a car to crash, which helps us to design an even better car, of course.
Virtual testing.
Virtual testing, and actually finding out, you know, a lot of things, and designing and, of course, facilitating how we work on developing the car. Another thing is, of course, just any of these devices, right? That helps crash testing as well. The cameras and the sensors and how we measure and how precise we can be in that, I would say. What hasn't changed is, of course, how people get injured, right? We are still the same. We can take the same kind of forces. Protecting people is about using the same principles still. So that hasn't changed. So in that sense, we still strive for the same thing.
But the change to computers is big, you know.
Yeah, it's
20
huge.
years ago, it was really hard to get data. And now we're drowning in it, so you have to be very selective about, you know, what you allow and what data you use, or otherwise you're stuck analyzing forever. So it's like one end to the other of the pendulum. It's swung completely.
As I've seen, you have concept cars that are autonomous driving. Obviously, because of the arrangement of the seats inside the car, there have to be other kind of, I don't know, safety systems that you have to use. Are you ready for this kind of, do you work at something like this? Because, you know, there are seats rear facing and everything. Airbags should have other forms, or I don't know, other placements.
I think, I mean, again, people are the same, right? And we've crashed in all directions already, if you look at real-world accidents. So obviously, like, understanding what the human body can take and how you need to protect it in every direction, we kind of built that understanding since long. So then, of course, if you change the seating, you have to design for that and protect for that. But I don't think, I mean, it's about evolving the car and developing the car and taking care of making sure that those principles of protecting people are taken care of.
And I think if you think about it conceptually, right, today you can either crash from behind or from the front or from the side.
Yeah.
So if you flip the seat, you still only can crash from the front or from the rear.
I see.
Yeah.
So the principle is the same.
The principles are the same.
Principles are the
What
same.
is challenging is if you move from like sitting up to lying down or something completely different that hasn't been done today.
Okay.
So, you know, sitting up all directions fine, but what happens when you start doing radical change to the interior? That's more of a challenge and a lot of concept work ongoing. If you need it, because that's also an open question, right?
Yeah, right. That, because being myself quite prone to car sickness, I'm not so sure about facing rearward. I don't know where you are, but when I can choose, I face forward.
Lying down, not so much.
No, not so much. So, well, let's see about the preferred direction of travel.
Are there new challenges introduced by electric cars? Challenges to safety and security, including the battery placement, or?
I think, I mean, we always have to think about, from what we know about the field and the real world and what could happen to a car, we have to combine that with how is this car designed, what are the protection need. And for a battery vehicle, we have batteries in the car, right? And those are a bit, you know, they are a bit sensitive. They want a certain temperature, they don't want to get deformed, and they are like the heart of the electric vehicle and needs protection. So of course we have to work with that and make sure they are protected just as the passengers. So that is challenging in one way, or it's like a design target to do that. And then again, we don't have the big powertrain in front of the passengers, so that is somewhat easier then. So I'd say it's like, yeah, it's different, but it's
like having an extra passenger, right? You know, someone who is sensitive, who does not like violence, and who can, you know, be pretty angry if you beat them up too much. So I think what we did is treat them kind of like humans, right? We put them inside the same...
Less comfortable.
Yeah, less comfortable. We use them as floor, but we put them inside the same safety cage, we call it, as we put people.
Yeah.
They need the same protection.
But progressively, I think the hood is gonna diminish in size and even maybe disappear one day, because you don't need all this size of the engine in front. So maybe people will be closer to the windshield. I mean, there will be no big zone of deformation.
Yeah, I mean, there's still the laws of physics. And if you think about how do you protect a person traveling at speed, if we don't even talk about a car anymore, if you're traveling at high speed and you want to abruptly stop, you have to be protected from two things. One is like injury to your body, and the other one is actually the stopping itself. I mean, we can't take a stop that is too fast, because you will just get injured by your internal organs moving. So you can't take endless acceleration, and you can't take deformation to your body. That's what we need to protect people from. So of course, with the car front is there and absorbing the energy of the crash, making sure we stop before intrusion starts to move on to the passenger, but also to ensure that we use a certain distance. So there's limitations to how fast you can stop. If you think about it, it's like if you, instead of crashing a car, kind of falls down, it's like if the equivalent of having no hood and just crashing would be smashing onto the floor, while having this front deforming in front of you is like landing in that firefighter carpet, you know, because you're kind of slowed down before you reach the hard.
Yeah, I mean,
surface.
if you jump from 10 meters,
you prefer the firefighter carpet,
I
right?
prefer carpet or water, because the slowing down happens a lot slower than with asphalt.
But then it would be like,
Same height.
it's comparing, then it's like diving compared to the flats landing on water. That's the same, right? You know that feeling? Diving is better.
Yeah, of course.
Done that.
Yeah.
So you want some
Distance.
protection distance. You can't protect from no distance at all.
Yeah.
Laws of physics.
How do electric cars handle that crashes in comparison with the IC cars? Because they are pretty heavier, and I think that the inertia is bigger. On the other side, you have more room to play.
Exactly,
Because there's a small...
Because what you want to do then, you still want to use that distance to stop that we spoke about, right? And how do you do that then? Well, you design the strength of the front structure to take care of the energy you bring into the crash. So what you do is basically, if you have more load to carry, you make the structure stronger, so it still uses that distance. So you can still, you know, play with those.
Yeah, ideally you want to crush the front maximally and keep the cabin completely intact. No change. So
that would be
a buffer.
Yeah.
In that sense.
And what is the maximum speed for a crash test here?
So the lab can do a truck at 80 and a passenger vehicle at, I think, 120, yeah. And we can actually, I don't know if you noticed, and we didn't have much time to talk about it, but we're on top of the tunnel the car was in, coming into the pole. On the opposite side is another tunnel, and the big kind of barrier, or the big concrete thing, it can actually move on air, so it can air cushion. It can move out of the way, and we can have two cars crash into each other. And the far tunnel can do a 90-degree angle, so we can crash two cars into each other at any angle. So the lab itself is built to actually, for us to be able to replicate what happens on field and make sure we can, you know, replicate it, investigate, how can we improve, etc., and learn from it.
But when you have this whole range from 0 to 120 or something, some think it's like, oh, why not do everything in 120 to be really sure? But it doesn't really work that way, because there's so much energy in 120 that if you design a car for that, it's probably going to kill you in low speed, because it's not going to deform at all in the front. So we have to select, we have to pick our crashes based on what we know are typical crash speeds. Like if people crash in 50, then that's what we should design for.
And that's actually something, exactly what you say, is something we bring into the front structure design, for instance, that the very front part of the car is softer, because if you crash at very low speed, you don't want to not the super low, but decently low speed, you don't want to instantly stop because then you still get hurt. So you want a certain deformation at that speed, and then it's progressively stronger. So,
yeah, so you can be a little clever about that.
yeah, you can make some choices.
How do you approach safety in different types of cars? What are the differences? For example, because now we are talking about the EX90, but we will see tomorrow the EX30. There are two different types of cars. How do you approach the safety levels so that they remain at the Volvo,
the Volvo standard? Yeah, well, again, it's really about, we kind of learned from the real world what could possibly happen to you and what do we need to protect you from. And then out of the design of every car, we of course have to make sure it meets the same level of protection. And it's quite different cars, as you say. EX30 is smaller than EX90, less weight. So of course that front structure is different than the one of EX90 in order to use all that space and protect you when needed. But it's still the same kind of principle thinking with safety cage, let's protect you, let's make restraints that use the interior distances to slow you down and have you...
But it's probably worth keeping in mind that this, like, going from 50 or 80 to 0 in half a meter, it's a challenge. It's not easy, which means there are no freebies. It's not given that you can just take, oh, we designed this car this way, let's make this car the same, because it doesn't work that way. So every car is a new design in that sense. Safety is always, as you usually say, safety is an achievement. You pay for it in hours and of engineering and real money. Knowing how to approach the problem. It's like puzzle solving. If you're good at puzzles, you can do it in less time than the competition, and you'll have a good puzzle out in, a good time. But it's never for free, and it's always trying to get it right at this edge of performance within that vehicle, whatever it's spec'd to be.
But do you start envisioning safety as an upgradable path for a certain model? For example, the EX90 has the LiDAR, the EX30 does not, but maybe it will have it in the future. So how do you continue to evolve?
Yeah, there's different kinds of upgrades, right? So what we've made sure first is that we can actually, well, we do that today. I mean, we upgrade our cars with software in the workshops. Going to over the air makes that happen faster.
And with more convenience.
Exactly, but what makes for a meaningful upgrade is, of course, that you learn something new that you didn't know when you designed the cars. Otherwise, you would have put that in already, right? So first, you actually have to learn something worth upgrading to. And then hardware is hard to upgrade. Software is much easier. So retrofitting hardware, that's more of a challenge. But if you, from one more complex sensor set, can understand the world in a way that if you know this is how it works, then our less complex sensor set can do the same, then of course you can transport the knowledge, even if you don't transport the hardware, so to speak. So upgrading comes in many forms, but first and foremost you have to learn something that's worth upgrading
Worth
to.
doing.
There's, from our perspective, then there's a lot of things people want to upgrade to just because. Not our business. Not answering questions on that.
Oh, sorry. Just a detail about today. The car didn't have hood or bumper in the front. Is there a different objective today? Because it's not the real conditions when you have hood, you have the bumpers and all the elements of the car.
I think some elements of the car is really design features that makes it looks really, really nice. The true kind of structural performance is in the structure, hidden underneath that nice surface. So a hood actually carries very little load. It folds easy, and we make sure in different crash tests that it doesn't fold in any bad way and that it's handled. And sometimes we leave it out of crash tests because we want to see what happens in the engine bay, and we want to see the structural parts, which are really key to safety performance. So
and design won't let us show our structures.
No, they kind of
else.
still want that hood on.
Yeah.
And the electric cars?
Yeah.
The electric cars, how secure are they against fire compared to the ACE cars?
As secure as we can make them, right?
Yeah.
Because a lot of people now are when they see electric car burning, and you know it's very hard to stop this thing. So how secure is this car?
What we make sure is, of course, that in any crash, the batteries are protected, as we said, with the structure, etc. And then disconnected after crash. So when it comes to crash, we make sure they are unharmed and disconnected from the car. And then we of course have a full set of experts on batteries, fulfilling Volvo standards on how safe are the batteries as such as when functioning, etc. But that's a separate set of experts.
Yeah,
happily.
the battery in use is one part. That's not our domain, but making sure it doesn't, you know, misbehave after crashes, that we do.
That's what we do.
And then it's really important. I mean, you can slow it down pretty fast, but you can't twist and brake. So you want to avoid that, and you don't want connection. It's a metal car, right? So we shoot the connectors. I think at least in some models we use pyrotechnics, like boom, blow away the connectors, and you're not connected to the car anymore.
And then
the hood and the front bumper are pretty much elements of design, let's say.
Yeah.
Let's make this exercise of imagination. On one side are the designers, which they are dreamers, and they can do whatever lines they want, whatever surfaces they want. On the other side is you, and you say, no, I don't like this hood because the pedestrian could be hit or something like this. The question is, did it happen before, or it happens for you to change certain lines of the car because they don't fit to your, I don't know, purpose, not to hurt the pedestrians, the bicyclists, everything?
Well, we never say no to design, don't we? We always say yes, but in a
Yes,
different
but.
way.
No, but
that was the catch.
Yeah. No, I think we have a lot of dialogue with designers, of course, and they can be pretty intense, but it's very often around, I think at Volvo Cars, honestly, safety is not the task of one team. It's not like the 200 people of Safety Center, we care about safety and go, push on everyone else. It's really in the Volvo team thinking that this is what we aim for. So it's more of a pool of knowledge because of course every designer can't have learned what every safety engineer knows. So I would say it's an intense collaboration, and yes, I would say it might affect the lines, but it's the designers still draw the lines, right? So it's they still design with the input from safety engineers, of course.
And it's really in Volvo, since I'm on the collision avoidance and driver behavior side of things, I meet with design and user experience people a lot, and often I have to like calm them down.
Yeah, true.
That's not a risk. Like you don't have to be afraid of killing people because you did this interface. It's okay. It's it's sorted. It's handled. So it's everyone's concerned.
Which is here you do crash tests for pedestrians or for bicyclists, only for inside the car?
This crash lab doesn't. We actually do pedestrian tests, but that's a different lab. Yeah.
I see.
So it doesn't. We don't do them here.
Dummies for pedestrians. We have for bicycles. We have for motorcycles. We have for pretty much anything. There's even a moose dummy hanging down there. You can see it from here. Yeah. It's near the back door. If you see an orange tube, from an engineering perspective, that's a moose. and then now you maybe understand why design won't let us design the cars.
True.
What about your customers? Do they have other objectives than, let's say, I don't know, I don't want to give brand names, other car manufacturers, premium car manufacturers, customers, I mean, they are more, you think that they look for safety more than for other features? I mean, we've made safety one of, it's definitely in our DNA. We are quite clear on aiming for very high safety levels. So I would kind of, working with safety myself and being passionate about it, I kind of hope that's something customers cares about. So I wouldn't say they are worried. I think they are just have it as a priority maybe. That's one of the aspects they consider for buying a car.
what they consider, what other car brand buyers consider, I wouldn't dare guess at, but
we hope, right? Because
yeah.
that's the nice thing about working with safety. We really hope everyone else is too.
True.
It would be a great thing if everyone
we
had
don't
super
mind.
safe cars.
No.
That would be okay.
And your purpose, your aim is that nobody is killed in a Volvo car, right? Do you think it's really achievable?
I mean, that's really a goal we are aiming for. It's guiding our mindset that we care about everyone and we want to avoid any crash.
If that's not your focus, you're never going to get there. Then whether it's actually practically possible, we can't predict the future. In that sense, I have worked as crash investigators. There are the weirdest crashes, like airplanes landing on cars. It's like,
yeah,
what do we do? But the mindset is there. If you don't strive for that, then you're not going to get there anyway.
But safety is not only about crash tests. It's also about systems and all sorts of equipment that help the driver and also the people
avoiding
around the car, avoiding the car. And we are transitioning, at least in part, to autonomous driving. How is this going to impact your work?
It impacts a lot. There's huge potential in making sure we don't hit stuff, and using advanced sensing to do that is a great opportunity. Obviously, if the car is going to do that, it's going to have to act on prediction, because again, you can never be sure. So you will have to make decisions on stopping or steering in situations that the car thinks are not very good or threatening in some way. So we can do that, but then at the same time, we have to do it in a way where people think, thank you, car. No, that is a stupid car. So it's interesting, the more technologically capable the vehicle becomes, the more focused Volvo becomes on behavior research. Because only if you understand, how do I do this in a way that makes sure the customer actually likes it, and we still don't crash, obviously. Only when you know this, can you design a car that can do that. So we're complementing all our crash investigations from actual crashes with trying to understand how people work and what makes sense. And much of it is very simple. It's like, if we warn you for a threat, then there should probably be something you think is threatening when you look at the windshield. And if we brake, it should be for a good reason, where you can see that, yeah, I can see I would have, I had it, I got it, no problem, but I can realize that had I didn't done something, then the car would have been in trouble. So that's designing a interaction with the driver where what they perceive as safety actions also turn into real safety. That's the new challenge, if you will.
Speaking about false positives.
False positives, yes. And obviously there's an engineering definition of false positives, and we can't send an engineer into every car to explain to the customer how they should think about this. So we are designing like one solution for 1 million customers that should work with every person. So it's a bit challenging, but it's very fun.
But at the same time, we spoke of what has happened over the last 20 years, and I think this is an area where it's moving very fast with the computer capacity, the camera capacity. So in the EX90, we're launching a complete new platform of how well we can understand the world around us. And as you say, we want to kind of predict, but it's good to understand what is going on around the car, of course, to be able to say what is the good thing to do here. And then, of course, in the EX90, we also add the interior sensing, where we can actually start looking at, and where are you? Are you on board here? Do you, so that we don't, knowing the world and predicting is difficult. And if we keep warning people every time the system gets worried, you will soon stop listening, right? We all know the cry wolf effect, like, no, never mind anymore. It keeps beeping, you'll just get annoyed. So of course, this is the new era, I think, for the car industry. And just with these capacities, we can really move towards not crashing at all.
Yeah, you can think of the like the driver understanding system, which we have in the X90 for the first time, it's really targeting the false positives, like how much or what the car would have done had we not known you were in control can we take away. Because when we do that, then the remaining stuff actually becomes true positives. And if you have the right ratio, like if you do enough true positives in relation to the false ones, you get trust. People start trusting you. And there's actually numbers on that. Like, let's say you have a few million you want to invest, right? Typical thing that happens any week.
Yeah.
Yes.
All the time.
And you go to a friend and say, where do I put this money? And they give you like, yeah, you should put it here. And this happens regular basis, of course. Now, if this friend is right 50% of the time, then of course the friend is wrong also 50% of the time. So talking to him is like talking to chance. You could flip a coin and get the same result. So even translated to the world of cars, even if we get it right half the time, that's chance. You never know whether it's going to be trustworthy or not. But you don't have to be right all the time. You don't need to nail it 100%. People want to trust. So if you get it right like 7 or 8 times out of 10, then people start to trust. Yeah, it's mostly right. Yeah, I'll go with this guy. You know, it's okay. He's wrong a couple of times, but usually it comes out to my benefit. So that's what we're aiming for. We need to take false positives out to the point where we can actually have this ratio where people start trusting it, which is
and of course also keep the true positives.
We
want to keep them contained, right? We don't want to miss out on those.
We want to make more of those, and that's also easier if you know where drivers' attention are, and if you know pretty much whether you're having a normal day or whether you're not having a very good day.
Or actually a day when you're fully human. I think that's what it's about, right? It's protecting people is about embracing the fact that we are human, because we are always very good at that. But that means we are worried and we are sleepy and we are, you know, thinking of something else, maybe even being happy can, you know, and being distracted sometimes. And I think, I mean, that's the thinking. Let's be humans and find out how we support when needed, with the help needed.